Okay, so let's look at the first poll. We are going to try to find the output of this. So the output is, and yeah, somebody actually forgot to spell. So that's interesting. So what is the value of total when I call this function? Total is 20, gain is 30. So new total is 20 minus 30 is negative 10, okay? And then the new total is max of 0 or negative 10, which is 0, right? Okay, so I'm going to return total, which is, that's right. So the correct output is this, except if you are kind of spell checking, there is no correct output. But it should be the first one, right? Oh. Wrong, awful poll, all right. So what does that teach you? What does that teach you? Read carefully, right? So don't read it like you are, don't read into what it's supposed to be. Don't read it as exactly what is, because this will be what we will see in the exam. Okay, let's do the second one. How about this one? What is the difference here? This looks pretty similar, except for there is no return, okay? So what happens if I print this function, but it has no return? It will actually output none, but we have not seen that, but it will not return 20, 10, or minus 10, or anything like that, right? Because it returns nothing, okay? So in fact, it should be none of the above, which you could have guessed because I just added that. I tried to add it to the previous poll, but it was too late, it didn't allow me. But, okay, so most of you saw that, that's good, okay? So if you didn't, remember, hey guys, too much noise, okay? If you didn't see that, okay, this is an important thing that we will talk again, but you will have to watch out in your code. Okay, so now this is much more tricky because we haven't really seen it, but we are going to talk a lot about it. Okay, so you have spam xy. So x is 3, y is 6. I am going to call spam of x and y. So this x and y and this x and y are not the same, right? The x and y in spam is like Mr. Meesik's x and y, right? So currently the x has value 3, y has value 6, but they are internal to the function, right? So what is the value of x after this? So you have y divided by x is 2, times 4 is 8, plus 3 is 11, plus x is 14, right? So x in this case is 14, so this function is going to return 14, right? So this c is going to return 14. Does it change this x? No, because the x in spam is totally different than the x's outside. So what will that print? 3, 6, and 14, okay, which would be this. Okay, so if you have the other answers, do not feel bad because, this is something very, very subtle. But remember that whatever happens in the function stays in the function. Yeah? Except for the next poll, which will make me a liar. Okay. Now, this is something we haven't actually seen, so don't feel bad if you have no idea what's going on, but this is very, very important. Okay, so this is the last one. And now, even though it's subtle, this is very, very different. So now, in this function called egg, as you know, Monty Python reference, eggs and spam. So this function egg has an x here, right? But is there an x defined in the function? No. This is bad. Don't do this. Okay? I'm just showing you what happens, but this is not how we want to program. So since there is no x inside the function, what will it do? It will not yet give an error, because it's Python, it's super nice. It will look around to see if there's another x outside of the function. Okay? Is there an... Yeah, well, at the time I call this function, there is actually no x, right? This apparently is more tricky than I thought. When I call this function, x is actually not yet even defined, right? Because x is going to be defined in the next. If x equals 2 was before, this would work. But the x is equal to 2 comes after I call the function, because at the time I call this function, nothing happens. In fact, it will give an error. But if I put x equals to 2 before, it would actually work. Isn't this madness? All right, so you don't want to write your programs where these kinds of crazy things will actually change how your program works. You're going to tell me it works? No. I'm sorry?
Do you need a comma between x and y?
No, that's a totally different thing, but we will talk on Thursday. The point is this, okay? I don't want my function to look out for something outside of the function, okay? Because otherwise you will get all sorts of different behavior. For changing one line, your function either works or your program totally fails. This is madness, right? You don't want that. So we would like to return error. And everybody got here, so I'm excited, okay? But remember that you would actually not get an error if you just change these two lines. Because if I had x's here before this, it would see an x. So what we call that x is a global variable. It's actually looking for x outside of the function that is not local to the function, but it's global to the program. And it's going to reuse that, but this is not something we want because it is going to lead to very, very difficult to debug problems. Okay? So this is something we are going to really kind of calm down and say, don't do that often. So with that, I am going to close this and try to change to, it worked, all right, to this function that we just did. And then we will actually play with this after we do some of the lecture 6. Okay? So this is the function we did at the end of class. It was giving some sort of a thank you note to a person who, you know, we hopefully like. So I was asked a few questions. For example, what about this? So this slash sign tells me that this one long line of code continues in the next line. So it allows me to have code that goes multiple lines. So I could do the same thing here. Okay. So basically, this function, what it does is it creates a string given the name of a person and a gift, and then returns the string. What do I do when I take the string? I will print it, right? So this is the case of a function that doesn't do anything so exciting because all that it does is actually print something. So in this very strange case, I may allow my function to not return anything because that's all I'm going to do anyway. So instead of returning the string, I am going to call print. Okay? So this function now is a new function that returns nothing. And I want to dedicate this kind of function to only functions that their job is to print something. Okay? You can do the same thing. You can have a function that returns a string, but you can also just print that string and you will be fine. But how we call that function is going to be important. So if you have a function, let's create a function first. So I'm going to create a function that does nothing. That does nothing but just print something. Okay? So to call this function, you can just call the function. When you call the function, what it will do is it will print something. What? It's not missing anything. Oh yeah, there's missing any here. All right. Okay. So if I call this function, it does its job, which is to print something, and it's done. If I call it like this, what will it do? So it will first call the function will print whatever it does, and it will disappear, because it doesn't actually return anything. But when you say print function, what you're trying to do is print what the function returns, but what the function returns is nothing. And in Python, nothing is something called none. So what it will do is this. It will say, okay, this is because I called the function, and now I'm going to return what the function is returning. I'm going to print it, but what the function is returning is nothing. If you want to see this in action, you can also do this. Let's say I call this function. I think it's actually me6, not me6. But anyway. So since I call the function, it will print, and then take whatever the function returns, assign it to x. If I want to print x, x is the strange object that has value called none. Okay? You will see this over and over, and it's so confusing. Because of that, we tell everybody, just make sure all your functions return something. So from now on, if you want to write a function that returns nothing, it is your responsibility to learn about none. Okay? So because of that, I should no longer print the function. I should actually just call the function. Okay? So we were nice to our uncle, but in fact, maybe we actually did not want to really always thank everybody so politely, but we wanted to thank them depending on the gift that they sent. Right? Some gifts are better than the others, so you want to actually have a different program depending on what the gift is. So that brings us to today's lecture, decisions. Okay? So now we are going to get fancy, and we are going to change how our program functions based on different conditions. So to be able to do that, we actually have to have a way to define different conditions. To do that, we are going to introduce a new data type. So currently, what data types do we know? We know integer, float, string, right? So we know three things. So we are going to introduce a new data type called Boolean. All programming languages have a Boolean data type. A Boolean data type only has two values, true or false. So you can actually use any function, any variable, but generally it is good to have variable names that kind of tell you what you are trying to represent with that Boolean. For example, is this class finished? No. You still have to sit here for some more time. Is the summer over? Sadly true. So you can basically print variables in the same way. And you can take an expression and then evaluate it to be true or false. So remember, a mathematical expression returns you a number, whereas a condition returns you true or false. So conditions like comparison. Is 1 greater than 2? False. Is it equal to 2? False. So boring, isn't it? 1 is less than 2? False. What about x is equal 3, y is equal to 4, x is greater than y? False. Okay. How about, is x equals to 3? Is it x equal to 3? Okay. But this is actually not going to check if x is equal to 3. This will, what will this do? Set x to 3, right? So to distinguish between the two, we are going to use two equals. Equal, equal. Okay? And this is where you're going to make the same mistake over and over, and it's very hard to catch this mistake in Python because it's not going to complain. But you can check if some value is equal to another value, but you have to use two equals, otherwise it becomes an assignment. What you can do is you can actually write conditions and assign them to a variable too. So you can say, currently the time is 2:50. Okay. So I would say, are we finished, is going to be time is equal to 3:20. Okay. So what this will do is it will evaluate this expression. This expression happens to be one that returns true or false, and it will assign it to this variable. So what should be the value of finished? False, because time is not equal to 3:20. Okay, so let's do a little exercise. We have to do it a little fast because I'm running a little low on time. So let's try to do these exercises quickly, and then we will move on to a couple more things. All right. Is A less than B? So it will be false. Now remember that it's false with a capital F and lowercase a-l-s-e, right? So the case is important. Otherwise, it will not understand it's the constant true or false. Is A less than absolute value of B? 1.6 is less than 1.7, right? So this is true. Yeah, I don't know how to make this bigger, smaller. Let's see. There are going to be massive truths and false. Okay. Is A greater than C? 1.6 greater than or equal to C? No. All right. False. S is less than T? Oh yeah, I didn't teach you that, did I? Okay. So is there an ordering among strings? Yes, there is. This is a problem because the ordering has changed. Okay, so strings are also ordered with less than or equal to, but string ordering is basically dictionary ordering. Okay, so would high come before good in the dictionary? Does H come before G? No. So is S less than T? Yes, right? Because it's the reverse. It says high is less than G. No, it is false. Right? We'll come back to string ordering later. I am sorry. Okay, so is T equal to U? T is equal to V. So this is good. This is good. Are they the same? No, because they are different strings. They basically have the same letters, but one is uppercase, one is lowercase. Is U the same as W? Yep. Okay. And finally, is B less than Y? So, error. Good job. Y undefined. Okay. Now let's do one more. We are going to say U is equal to W, U is equal to V, and U is equal to W. So what is U? Is by, and W is by. Okay? So let's try to do this. All right. All right. So the expression U equals W, U equal W, returns true. Okay? So it's an expression that returns a new value. It returns true. Okay? So does it change U or W? No, because it is like saying x is less than 5 or x plus 5. It's just an expression. So how about U equals W? It assigns the value of W to U. Okay? After you do the first line, this one will always return true, right? Regardless of what the value of W was. So let's say U was 2 and W was 5. U equals W will be false. But if you do U is equal to W, now U and W are both 5. So now they are going to be true. Okay? Be very careful. When you have double equal, that has a very specific meaning. It is not going to change anything unless you take the value of it, assign it to a variable, a Boolean variable. The reason that we all want to do this is because we want to use this in programs. So this is where it's going to get a little bit interesting. So this is like one of the basic tenets of programming. You want to write a program that's not always going to do the same thing. It's going to basically do something different based on a condition. So you can write that condition by if and else statement. Okay? So generally the idea is that your program is going on its merry way. But if the condition there is true, only then it's going to do what is in this block. And you can also have an else block that will do if the condition is false. Okay? So let me try to write a very, very simple example to show. Then we'll go from there. So let's read a value. Okay. So okay. I always like to be very specific. All right. So this is kind of a life coach trying to be nice. And it asks you, how long did you work out? You say 5 minutes. It says, that's great. Well, maybe it's not so great if you worked out 5 minutes. I want to kind of, share my praise for you for maybe if you worked out more than, let's say 20, okay? All right, so I don't want to always say, you did great. I want to say that if you actually worked out more than 20 minutes, then I'm going to say something nice, right? I will not be like annoying like in Whiplash or something, but still, I will share my praise. I actually was using this app, and it always had something nice to say, even though when I sucked. So I really liked it. I'm not saying you should do this, but for the purpose of this, so let's say that I only want to tell you that you did good if, and in fact, let's change this to minutes so that it's actually, I'm trying to use meaningful names. Okay, so I want to say if the number of minutes you worked out is greater than or equal to 20, okay, only then I'm going to print that is great. So the idea is that whenever you have an if statement, the part of your code that you only want to execute if this condition is true becomes a block. And so you indent it. So if you had multiple things to say, you can indent it all below this one, right? So you can say, great job. Okay. It seems that I really don't care if you did not do the 20 minutes or at least more. But, you know, my man is great. So everything else will only happen if I enter something that is greater than or equal to 20. Okay, so let's do that. So if I enter 5 minutes, it just says you worked out 5 minutes, and I have nothing to say to you. You know, sad, but that's true. If you say, well, I worked out 25 minutes, now it's telling me all of these other things that I will tell conditional on the fact that you worked out more than 20 minutes. Okay? Let's actually change this program a little bit. Okay? So I'm going to change it so that I have these 3 pieces of code, right? So this piece of code always says that you worked out this much, regardless of how many minutes you worked out. This piece of code gives me additional praise if I worked out hard, right? This is like your little Fitbit, okay? And then the last part, is it conditional on the time? Is it? So since it's not indented anymore, it's actually not conditional on the if statement, so it will always print, regardless of what it is, right? So you can try that. So you see that when I do 5, which is not greater than 20, this does not print at all. If I do 20, now I print all 3 pieces of code, right? So this is the part that will only print if it is conditional on what you have done. This is the part you need for the last part of part 3 of homework, okay? So I give you one if statement, but you will need to practice more if statements for the exam, so we will be doing a lot of this. Any questions so far? Okay. So, yes?
What if you worked out -5 minutes?
Well, it's still not so great. But we can have, you know, remarks for people who are trying to do strange things. I actually have this, so there is like this very famous, you know, quality engineer, because, you know, you basically write your program for the normal user and the values they will enter, and then what do you find out? There are no normal users. They will enter all sorts of random things. Okay, so let's try to write slightly better, okay? So let's say that if you worked out greater than 20, that is great. But otherwise, I still want to give you some sort of a message that tells you that, you know, maybe you should do better. What should I say? Well, that is maybe true. Let's try to be more positive. Well, let's say something like you can benefit more with a longer exercise. Okay. Otherwise, you will not benefit from your Sodexo food. Okay. So now my program has different parts. Okay. So what will happen? Okay. So this part will execute only if x is greater than 20. This part is going to execute only if x is less than 20, including -5. Okay? So are we okay so far? So this else is like saying that you will only do it if x is less than x is less than 20. Okay? So let's try to see that. So if I enter 5, it's going to print out this part, then it's going to print out this part because it's actually less than. Okay? You can benefit more from a longer exercise. Let's try to be a little bit more English-like. Okay? Whereas if I do 20, I will only execute 1. So now I have an if-then-else statement. The top part is only executed if this condition is true, and the bottom part is executed if this part is true. How about people who exercise a lot more than 20 minutes, and they are like, this is not really showing me enough encouragement? Yeah? So what if you exercised for how long? 2 hours. You ran for 15 miles. There are such people here, I assume, right? Yes, okay. So now I want to change it so that I have multiple categories. Okay? So to do that, I'm going to use this block. Okay? So now this block is basically a condition that goes in order. Now you have to become very, very careful about what you write. So let's try to show what that does. So you have a single if, but you can have many else if. Else if is just shortened to elif for Python, because Python likes to short. This is true. I don't know where you're going to make that one. Okay. And then you can have many else if, and then you can have one catch all W. Okay. Now these conditions are executed one at a time. Okay, they are not executed in kind of random order, right? So it's not like Python is going to come and look of all these conditions, which one matches. No, it's going to first do the first one. Okay, it's going to check this one first. Okay, if this one works, then it's going to do X and then it's done, right? Music is gone. If this one fails, if condition 1 is not true, only then I'm going to check for condition 2. Right? So this one implicitly says condition 1 is not true and condition 2 is true. If that works out, I am done. If that doesn't work out, only then I'm going to check this one. This one tells me condition 1 is not true, and condition 2 is not true, and condition 3 is true. Okay? If all of those fail, then I will come to the last else, which will tell me that, in fact, none of the above conditions were true, then do the else part. Okay? So let's try to use this to write what we want. We want to say something nice if you worked out more than an hour. Okay, let's do an hour. And then we want to write something else if you worked out less than an hour, but more than 20 minutes. And if all else fails, we can say you suck. Okay? Our standards are higher now. This is CS1. Okay, so let's try to write that one. So, which one should I put first? Should I check for greater than 20 first? No. What is the strongest condition I have? More than an hour, okay? And this will get easier by exercise. This is not just going to be something that comes as natural. You just have to exercise and then think about what it is doing. So if minutes is greater than equal to 60, I say, my man, all right, so what will I say? You are crushing it? Is that the right way to write it? Is this correct? Okay. Keep up the great work. Okay? So, if it is not greater than 60, but it is greater than 20. Okay? So now, this is only going to be true if minutes between 20 and 60, right? Because if I came to this part, I know for sure that it is not greater than 60, right? But it is greater than 20, so it's between 20 and 60. And if all else fails, I'm going to say you can benefit more from a longer exercise. Okay? All right, let's try that one. So if I write 55, what do I expect? That is great. If I write 65, okay, it's the top. And if I write -5, okay, it says that it can really help to do a little bit more. Which I understand is a challenge, but it actually will help you also with everything, including CS1. So let's see what happens if I do this in the incorrect order. So let's try a different version where I'm going to mess this up. Okay. Okay. So let's see what happens if I happen to execute it like this. Okay. So nothing in the world is preventing you from writing something really stupid. And nothing in the world is preventing me from making stupid mistakes. Okay? So it's not like it's smarter than you. So let's see what happens. Let's say I worked out 20 minutes today. What do we expect? That is great. Okay? What if I worked out 60 minutes today? Oops, sorry. Okay. Still that is great, because what happened is that it looked at the first thing, it saw it was right, and just printed it out, and it's done. What happens if I were to say 10 minutes? So is 10 minutes greater than 20? No. Then I'm going to check the next one. Is it greater than 60? No. Okay. Okay. So what happened is that middle part is not being used at all, right? Because I will never actually get there when it's actually greater than 60, because the first thing I check is greater than 20. If it is greater than 20, I will stop there. So this is kind of the important part. When you're using if statements, you actually have to learn how to do it. And we will come back there again and again. We will do this multiple times. So this is not the end of this, but remember that you need to write it in the correct logical order that makes sense. So one of the things that we learned when we first learned to do this is to actually write independent if statements for the same thing. So let's try and see what happens if I write the same thing, but using independent statement like this. Okay? So there is nothing that tells me that I should use if then else. I can also use multiple if statements. I can say, okay, if it is greater than 60, do this. If it's greater than 20, do this. And if it's less than 20, do that, right? So now you have to ask yourself, don't shout it out yet, will this produce the same exact program as the one before? Okay. Is this the same? Let's try and see. Okay, so let's run and see. So if is less than 20, let's say 10, it's the same. If it is greater than 20, let's say 25, that's fine. What about if it is 80 minutes? You worked out 80 minutes. That's pretty good. What will that do? Okay, so first, is it greater than 60? Yes. So it will print out something. Is it greater than 20? Yes, 60 is. 80 is greater than 20 as well, right? So it will print that out as well. It's not less than 20. In that case, it will not print it out. Okay? So if you really wanted to produce the same exact results as the previous one, this should be more specific. It should be minutes greater than 20 and less than 60, right? So you can actually write that. You can say minutes is greater than 20 and less than 60. Now, one of the things is that this program now will work exactly like the other one, but it is not as efficient because I am actually checking 3 if statements. As opposed to in the previous one, if the first one was true, I never had to check the other 2. Okay? So as we become more and more comfortable, we will see that it is better to use the if then else. But at first, if you are uncomfortable, you can learn the first if statement and then move to the else. But be very careful that if you have if then else, the else is conditioned on the if part. If you have independent if, each one is separate. So on Thursday, when we come in, we are going to finish up this. Please bring your notes with you because we have the part 3 left. We will do another poll, and then we will move on to a new topic.